Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello and welcome back to the podcast, and welcome along if this is your first time here. It's great to have you here. I hope that you're well. In this episode, we're going to start talking about thermochemistry and energetics in chemistry. Thermochemistry is a really big subject, but a really important subject. And it's really important because understanding the energy changes that go with chemical reactions is a vitally important part of understanding what's required to make a chemical reaction proceed, or what energy can be derived from a chemical reaction. So what do we mean by that? Well, we can use thermochemistry for working out the energy changes that happen in reactions. So we know that there are big energy changes when we combust fuels, but until we actually measure what that energy change is, we don't know which are the best fuels, which we'll get the most energy out of. We can also use thermochemistry to calculate the energy requirement that would be required to make a reaction go in the lab, and more importantly, in a chemical plant. So that will help chemical engineers when they're designing a chemical plant to make a particular reaction happen. Of course, that information is important for understanding the cost of making that reaction occur, because energy is going to be a large part of the costs. And we can simply use thermodynamics to predict whether or not a reaction is likely to occur or not. So we mentioned that we're going to measure energy changes, and we can do that both in theory or in practice. We can actually measure that energy change within the lab. What we haven't done yet is state what the unit of energy is. So the standard unit of energy is a joule, Joule. And actually a joule is quite a small amount of energy. So we don't usually use individual joules. We don't usually count individual joules of energy. We usually are looking at kilojoules. And when we're measuring energy changes or calculating them, we need to refer them to a quantity of the substance or substances involved in the reaction. And so we're measuring the number of kilojoules of energy change per mole of reactant or of substance. So joule is an amount of energy, but we're going to be measuring and calculating kilojoules per mole because that's a meaningful quantity to us. It's something that relates to how much energy change for the amount of whatever the substance is. Okay, so why do we get energy changes in reactions at all? Well, it's because chemical bonds contain energy. When we break a bond in order to make a chemical change, that requires energy to be put into the system. And when a new bond is formed, that gives out energy again. So the energy change is the difference between the amount of energy gained from creating the new bonds less the amount of energy required to break the old bonds that needed breaking to make that reaction occur. If that's a negative amount, in other words, we get a net gain of energy, more energy is given out than was required to go in, that's described as an exothermic reaction. Exothermic means we get energy out of the reaction overall, and we always give that a negative kilojoule per mole value. The opposite can occur. We can have an endothermic reaction, and that's a reaction that required more energy to break the bonds than was obtained from making the new bonds. So the energy change was considered positive. More energy was required to make the reaction occur than was obtained from the reaction, and we call that endothermic. How do we describe a reversible reaction and equilibrium? If you remember from a much earlier episode, we described a reversible reaction as being one that will happen both forwards and backwards and is able to reach an equilibrium where there is no net forward or backward reaction. In the case of a reversible reaction, the reaction in one direction will be exothermic, and the reaction in the opposite direction will be endothermic. Not only that, but the number of kilojoules per mole of energy will match. It will be negative in the exothermic direction and positive in the endothermic reaction, but the number will be the same. Okay, so what have we said today? We've said that thermodynamics is the study of energy change during chemical reactions. We said the unit of energy is the joule, and that the useful measure that we will be calculating and measuring is the number of kilojoules per mole of energy change. We need to be able to relate our energy change to a mole of substance, a mole of reactant. We also said that there is energy change because energy is required to break chemical bonds, and energy is given out by making chemical bonds. So in a chemical reaction, there will be an energy requirement for bonds to be broken and an amount of energy given out by new bonds being made. And overall, that energy change might be exothermic, meaning more energy is obtained than was required, or endothermic, a positive number, meaning that more energy was required to break the bonds than was obtained from the reaction. So I hope that's been useful. In the next few episodes, we'll be going more into enthalpy and enthalpy change and talking about Hess's law. So make sure you subscribe so you're listening to those episodes when they're available. Any questions on the topic we've talked about today, then please do come over to our Patreon community and ask those questions. That's the very best place to ask those questions. That's where I'll be publishing the answers to the questions you bring up. And at this point, I just want to say a big thank you to our latest Patreon, Keith Helinski. Thank you for your support of the podcast. It's really appreciated. For anyone else who wants to come and sign up and support the podcast for about the price of a cup of coffee, please come over to patreon.com/chemistry made simple. I'll put that link in the episode description too. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistry made simple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself and goodbye.